guys, welcome to the inverse functions portion of this program. Just a few notes. We are going to have a test on September 23rd, which is a little ways away, but just mark that on your calendar. And your homework tonight is going to be the pages 517, 4 through 8, multiples of 8, and a Delta math assignment. Okay, so there's a Delta math assignment as well as that homework pack. All right, so we're going to open up to 8.2 in inverse functions. I'm going to just move that down a little bit. And we're talking about inverses. So when we're talking about inverses, we're basically talking about equations that one equation and then how it undoes another equation, and we'll talk a little bit more about what that does. But it's basically, it's not really the opposite, but it's basically undoing. So you may want to think of, inverse operations when you solve equations. So the composition of a function f and its inverse, f of -1, that's how you describe it, is the identity function. Y equals x or x equals y. Now, keep in mind, this is the inverse. That little -1 up there does not mean reciprocal, it means the inverse. So to find out if they're the inverse, you're basically going to try and undo what's being done. So what's being done to x? We're subtracting 4, so to undo it, we would add 4. Right? That's undoing it, inverse operations. And in this situation, what's happening here is x is being cubed and added 1. So to undo that, we would basically take the cube root and subtract 1. Do I expect you to know this? No. I'm going to show you how to do this algebraically, okay? So here we go. That is kind of what we're doing. So you basically are trying to undo the function. All right. So when you, so if you have f and g, two functions, such that the composition of f of g of x would be x. So basically, if we were to take, up here, if this is the inverse, f of the inverse of x, so we take this equation right here, and I'm going to insert this one, -4, and then you know how I do it like this. So then I'm going to take this part and throw it in here. So x plus 4, when I work this out, I'll get x plus 4 minus 4, so I would get x. This is the definition. So this is what happens when you have two inverses. When you have a function and it's something that undoes that exact same function, then you get just plain x. Would that work here? Yes, let's see. So if we had f of, and it actually works the opposite way too. I'm not going to do that right now because I think that'll confuse you, but it does work if you want to try it. And then we do the x cubed. Let me take this off. The x cubed plus 1, and then I'm going to insert this portion, the cube root of x minus 1. So when I cube this whole thing, I'm going to get x minus 1 plus 1, which of course equals x. So that is how you make sure that it is a function. So we're going to kind of talk about that in a minute. So in order to determine algebraically if these are inverses functions of each other, here is how you do this. You just basically say f of g of x, that should equal x, or g of f of x. It doesn't matter. You can do it either way. should also equal x. Either one. So I'm going to take, if I want to do f of g of x, I'm going to take this equation, I'm going to write it out, and I'm going to leave a blank space where the x is, and I'm going to plug in my g of x, and then I'm going to solve it. And when I solve it, I would multiply this 1/4 times 12 plus 1/4 times 4x minus 3. And 1/4 times 12 is 3 plus 1/4 times 4x is x minus 3. 3 plus x minus 3 equals x. So that shows me, yes, they are inverses of each other. Okay, so that means this equation and this equation are inverses of each other. Okay, and you could do it the other way too. Pause the video and try and work it so that you are doing g of f of x equals. So you would have 12 plus 4 times, and then 1/4 x minus 3. Pause the video and just make sure that gets. And as you can see, when you work it out, it does. All right, moving on. So here is another. Let's see if these are inverses of each other. They look pretty close. Let's just double check. So I'm going to say f of g of x is going to be, and I'm going to take my f of x, f, and leave a blank where the x is, minus 2, and I'm going to insert 1/3 x plus 2. It's looking pretty good. And then I multiply my 3 out, so I get x plus, wait a minute here, that's going to be plus 6 minus 2, and I actually get x plus 4. This is not just x, so this is not, they are not inverses of each other. All right, so then the question becomes, how do you find the inverse of an equation? Well, I'm so glad you asked. Thank you. Thank you for bringing that up. How do you find the inverse? Well, I'm going to show you. So right here, this is step 1. Step 1, you're going to rewrite the equation where it's y equals. Replace f of x with y, step 1. So when I do that here, I'm going to get y equals 5x minus 7. So there's my step 1. Step 2, interchange x and y. Yes, that's exactly what it says. Switch x and y. So you're doing a little switcheroo. So instead of y, I'm going to put x equals 5, and instead of x, I'm going to put y minus 7. So I'm just switching them up. All I've done is I've switched them up. Step 3, solve for y. Boom. Okay, so now I'm going to use my inverse operations. First of all, you need to make sure, is this going to be a function? If it's not a function, then you got to stop right there. But so then if the new equation does not represent y as a function of x, the function f does not have an inverse function. If the new function does represent a function of x, solve the new equation for y. We'll talk about that in a minute. But, so I've got this, now I've got to solve the equation. So what's my first step? Well, I want to get this y by itself. I want to isolate the y. So I'm going to do my inverse operations. And so the first thing I'm going to do is add 7 to both sides, right? So I'm going to get x plus 7 equals 5y Then in order to get y by itself, I would divide both sides by 5, and I would get y equals x plus 7 divided by 5. And that is my inverse, ease. Then for the last step, just to show, I'm going to rewrite it with f of negative 1x, the inverse as y. So instead of y, I'm going to put this little sign here. So I would write f, the inverse equals x plus 7 divided by 5. And there you go. All right, let's do another one. So we've got step 1. We're going to do it in green. We've got step 1. Rewrite with y equals. So instead of f of x, I'm going to put y equals 3x cubed. Okay, or to the third power. Step 2, switch x and y. So I'm going to switch it where I get x equals 3 and then y to the third. Okay, so keep that in mind. You just switch them. Then my third step, solve for y. How would I do that? Well, in this, the first thing I'm going to do is divide by 3. I'm going to divide both sides by 3. So I get x divided by 3 equals y to the third. Then, how do I get rid of this cube root? Well, I'm going to take the cube root of both sides. So I take the cube root of this side and the cube root of this, which gives me y, because the cube root of y cubed equals y. If you don't know that, that's something we're going to be using a lot. All right, so now here is my answer, but my last and very important step is I'm going to rewrite with f of the inverse. So I'm going to rewrite this as the inverse is the cube root of x over 3. Now you could rewrite it down here as like this if you want. That is perfectly fine. You can flip on, whatever. All right. And the last one for this page, you've got y equals x squared. So I'm going to do step 1. It's already y equals. Step 2, so I've got y equals x squared, switch x and y, so I've got x equals y squared. Now, right here, I'm going to tell you this violates this rule. The function, this does not represent y as a function of x. And the reason being is if I were to graph it, I will show you. If I were to graph it, I already did, you would get this. And you can see from the vertical line test, this is your x equals y squared. Your vertical line test shows that x is got 2 values for one x value has 2 y values. So the vertical line test is violated. Therefore, this is not a function, in which case that just goes to show you that there is not an inverse. So this is not an inverse. This graph right here does not have an inverse. Okay? All right. Now, one thing that we did not do is verify. I used up all that space. I forgot to verify. Let's do that really super fast so that we cover all bases. If I were to verify that this is a function of this, how would I do that? Well, I'll show you. You're just going to do f of the inverse function of x. So I'm going to write 5, and instead of x, I'm going to put x plus 7 divided by 5 minus 7. Now when I multiply this out, the 5's cancel out, and I get x plus 7 minus 7. X plus minus 7 equals x. Perfect. That's exactly what I want. So I've checked my answer. What about this one over here? How can I verify? Well, I'm going to take my f of x and plug my inverse in. And I would get 3. And then instead of my x, I'm going to plug in the cube root of x divided by 3 and cube that. And now I know that the cube root of cubed is going to just give me what's inside of here. So I'm going to get 3 times. And this is why, because we're basically saying this is x divided by 3, right? 3 times. So when I multiply them all together, I'm going to get x cubed divided by 27 and the cube root. So this would be x cubed divided by 27. The cube root of that, the cube root of x cubed is x. The cube root of 27 is 3. All right, so if you weren't believing me on that. So I'm going to get x over 3, and then when I multiply those out, I get x. All right, so that has been verified. All right, moving on. Flipping it over. Okay, so if we were going to graph the inverses of these functions, basically what you need to know is that these graphs are reflections of each other across the y equals x line. So if I was to write that y equals x line, look at right here. I was going to basically create this. I'm going to do it in highlighter. And it would go through the origin. And you've got a one slope. Go like this. Just like that. Okay, so that's your y equals x line. And that's not really a line. It's just kind of a visual. So what's going to happen is when I graph it, if I were to fold the paper like that, then they would lay flat on top of each other. The two graphs that I'm about to, if they're inverses of each other. So I've got this line right here. How do I graph this line? How do I know this is a line? Well, because the exponent to the x is 1, right? It's to the first degree. Same with this. This is going to be a line to the first degree. I'm going to tell you a little secret as we go on, but not right this second. So I'm going to graph this. I'm going to go down 3 because my y-intercept is 3. 1, 2, 3, negative 3. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right. Or I could go down 2 to the left 1, down 2 to the left. Same thing. There's my line. Using a ruler so it's nice and pretty. And another thing I'm going to do is in red, I'm going to say, okay, because I want you to see this. When I create a table, and I could have put x, f of x here, but I'm just putting y. When I create a table, if I show my points, I'm going to say, all right, when x is 0, y is 3. When x is 1, y is negative 1. When x is 2, y is 1. And when x is 3, y is 3. I could go on and on and on for, and this would be 5. So there is the point of this red graph. Now I'm going to do the other graph in green. So my inverse graph is going to be in green. So how do I do that? Well, I know that if I put this in y equals mx plus b form, I would have to distribute the 1/2 and get this. So my y-intercept is going to be at 1.5, so right here, right? And my slope is 1/2, so I'm going to go up 1, and I have to be careful because, of course, I'm right in the middle, down 1/2, down 1/2. That is going to cross right there. And I'm kind of just trying to think of different points. Up 1/2. That's going to cross right there. So, because I also want to do a table for this line. And hopefully you're noticing that if I were to fold this paper on that yellow line, the red and the green lines would be touching perfectly. So the inverse table would basically look like this. When x is -3, y is 0. When x is, and I forgot, look at that, should be negative here. When x is 0, y is -3, sorry. When x is 1, -1, sorry, when x is -1, y is 1, that's this point right here. When x is negative or +1, y is 2. When x is 3, y is 3. And when x is 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, y is 4. And what you notice about these two tables is whatever x is, the y, that is flipped. Do you guys see that? So the x and the y's are flipped in every single point. Isn't that what we just did? In the other, we switched the x's and the y's. So that's really all we're doing, is just flipping the x's for the y's. And this creates your inverse. All right. Okay. And let me tell you where you're going to have to really be careful. Be careful when you've got x squared. And we're going to talk about that right now. So when you have a horizontal line test, a function f has an inverse function if and only if the horizontal line test intersects the graph at f at more than one point. This is called 1-to-1. So in this case, what you have to do is you say, okay, if you do the vertical line test, and I'm using the red line, if you notice the red line. If I use the vertical line test, it's only touching my ruler once as I bring it along, right? It's only touching my ruler once. Now, if I use the horizontal line test, it's also just going to touch my ruler once as I use a horizontal line. That means it can have an inverse. But let's just draw a quick sketch because I want to show you. If I was going to sketch this graph, it's going to be a parabola that is brought down to 1, 2. It's going to look about like this. So I know that this is a function. Y is a function of x because of the fact that my vertical line test is satisfied when I do this. For those of you, I'm doing the vertical line test, right? It's not touching my ruler more than one time at any one place. However, as we learned on the other page, this horizontal line test is not being met because it's touching my ruler at more than one point. So therefore, there is not going to be a inverse. It has to be one-to-one, meaning it satisfies the vertical line test and the horizontal line test, and the horizontal line test. Only then will there be an inverse. All right? So then, does this work? I don't know. Let's see. I'm just going to say you really only have to pay attention when you have, if you have a line, it's going to satisfy it. That's just pretty basic knowledge, that if you have a 1 degree function, it's going to satisfy. Can you see that? That would satisfy both the vertical line and the horizontal line test. So this would be graph the following functions using your calculator. Well, I graphed it on here, and it looks like this. And it satisfies, so yes, there would be an inverse. Okay, so my expectations are that you do your Delta Math assignment, do that first for sure. Then your homework, page 517. Starting with number 4, you're going to do multiples of 8. So you're going to do number 4, number 12, number 20. You add 8 every time. So number 28, 8 plus 28 is 36. All right, you just add 8, and then you will end up doing these problems up to 88. Okay, so the Delta Math assignment and those problems. Up to there. So these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 problems.